Hey guys, it's Miss Johnson and I'm here to bring you your notes for Unit 5, Notes 2. Today we're actually going to talk about graphing those quadratics that we identified all the parts of yesterday. So yesterday we spent a bunch of time talking about the parts of the parabola. Today we're actually going to put those quadratic equations on a graph. So let's just review from yesterday what we would identify from an equation like this. We'd have y equals negative x squared plus 6x plus 4. And we need to start by identifying the a, the b, and the c. So the a value is -1, b value is 6, c value is 4. Then we need to look at the vertex, and remember that vertex formula is the opposite of b over 2a. So I have, in this case, -6 divided by 2 times -1. That is -6 divided by -2, which is +3. So that's the x value of my vertex. So I can put that in as the first half. And I also know that that's going to be my axis of symmetry because they're the same thing. Then I got to go back and find the y value of the vertex because that's only half of it. So I plug that in and get y equals the opposite of 3 squared plus 6 times 3 plus 4. 3 squared is 9. The opposite of that is -9. And then 6 times 3 is 18 and plus 4. -9 plus 18 is 9. And then 13 is the y value. So that's a y value of my vertex. Then I can also identify the y-intercept. The y-intercept comes from that constant value at the end, which in this case is 4, that c value right there. And then the opening up or opening down comes from the a value, and in this case the a value is -1. So -1 tells us that it opens down. So that's just a review of all the things we talked about yesterday. Now let's get into what we're going to do today. The first thing that we're going to do today is find the vertex. Okay, so that's the very first thing that you want to do when you graph quadratics, because the vertex is the middle of our parabola, and we need to put the middle of the parabola on first. So do the opposite of b over 2a, then we take that and plug it back in to find the y value and write those as an ordered pair. Now let's do that as an example. Let's flip to problem number 2. So turn your page over to the back to problem number 2 and let's find the vertex of that question. So I have the opposite of b over 2a. I'll come up here. So x is equal to, in this case, my b value is -6 and my a value is -3. So 2 times -3. So it's -6 over -6. -2 times, or -3 times 2 is -6. And I get a +1. And then when I plug that back in to get the y value, I have y is equal to -3 times 1 squared plus 6 times 1 plus 4. -3 times 1 squared. 1 squared is 1, and 1 times -3 is -3. 6 times 1 is 6. And then plus 4. So that's -3 plus 6, which is 3, plus 4, which is 7. So the vertex, we're going to throw in the very middle of that table. I'm going to put the vertex right in the middle. So my vertex is 1, 7 there. Okay, so now let's go on to the next thing. So now we've got the vertex. The next thing we have to do is we have to make a table. And by making a table, we start with the vertex in the middle, like I had already put on that table there. So I put my vertex in the middle. Then I need to go 2x values to the left of the coordinate plane and 2x values to the right on the coordinate plane. So it's kind of like counting 2 backwards and 2 forwards. And then I fill in the y values for all of those. So now let's create the table for problem 2. So go back to problem 2 and see if you can finish creating that table. So I'm going to go 2x values before 1, and I'm going to go 2x values after 1. And then I need to go ahead and fill in all of the y values. So for the y values, I'm going to plug in 2. So I have y equals -3 times 2 squared plus 6 times 2 plus 4. 2 squared is 4 times -3 is -12. 6 times 2 is +12, and then plus 4. So that's going to give me the -12 and the +12 cancel out, and that leaves me with just 4. Then I got to do that with the 3. Y is equal to negative 3 times 3 squared plus 6 times 3 plus 4. And I have negative 3 times 9 plus 18 plus 4. That's negative 27 plus 18 plus 4. And I end up there getting negative 5. So that's my y value there. Okay. Okay, so now we got to go back and we got to plug in that 0 and that negative 1 as well. So the 0 is actually pretty easy because what happens here is when I plug in 0 for x, both of those first two terms are going to cancel out because multiplying by 0 makes them go away. 0 squared is 0, 0 times negative 3, gone. 6 times 0, gone. I'm left with just the 4, so that helps. And then the last one that I need to plug in is the negative 1. So that's y equals negative 3 times negative 1 squared plus 6 times negative 1 plus 4. Negative 1 squared is 1. 1 times negative 3 is negative 3. 6 times negative 1 is negative 6 plus 4. And I end up with y equaling negative 5 there. Right, negative 9 plus 4, which is negative 5. Okay, so now we need to actually put these on the coordinate plane. So the next thing that we're going to do is we're going to graph the values from the XY chart. So this is step 3 on that first page there, or I guess the next thing that we would do. The next thing we would do is put the values on the chart. So let's do that. When we do that, when we graph the function for number 2, here's my vertex, 1, 7. So I go over to 1 and up to 7. 1, 2, 3, 4, 5, 6, 7. There it is. And then I do 0, 4. And negative 1, negative 5 is way down here. And then if you'll notice, on the other side of the vertex, 2, 4 is right there. And 3, negative 5 is down here. So what you can see is that these have been reflected over the axis. So over the vertex. So let's take a look at that. Go back to those kind of uncovered steps that we had there. When we look at that graph, what we can see is that the points are mirrored on either side of the parabola. So we've got an axis of symmetry in the middle, and that's where that axis of symmetry goes through the vertex. So we can see that that's where it's symmetrical on the left side and the right side of the parabola. So if we draw in that axis of symmetry, it's right here. And the curved graph mirror images itself on either side of the parabola. And the nice thing about that is that as long as you're the same distance from the vertex, which we are here, when I went from 1 down to 0, that's only 1 unit, 1 up to 2 is only 1 unit, these y values are going to match. Same thing here, 2 units away from the vertex, those y values match. So because the parabolas are symmetrical over the axis of symmetry, then we've got y values that are corresponding. Okay, so we're going to go ahead and stop our video there for today, and we'll leave the rest of the examples to finish in class together. Don't forget to hop back to Schoology and take that quiz. Thanks for listening, and I will see you all tomorrow.